Hello everyone, and welcome back to the channel. Addressing modes in computer architecture refers to how the operands can be located. As we have seen before, an instruction usually has an opcode and several operands. The operand address field in a typical instruction is relatively small. Since instruction has to refer to an extensive range of locations in the memory and registers using this limited field, various addressing techniques have been employed to achieve this objective. In this video, we will examine modern computers' most common addressing modes. The first type of addressing mode is the immediate addressing mode. Immediate addressing mode is an addressing mode where the operand is directly specified in the instruction itself as a constant or immediate value rather than being stored in a register or memory location. This operand is immediate because it doesn't require an additional memory fetch to retrieve the value. Here, add is the opcode, A is the destination register, and 10 is the immediate operand. This instruction adds the constant value 10 directly to the current value of register A. Immediate addressing is useful for operations where we need a constant value, as it avoids additional memory access and speeds up execution. For example, setting counters, initializing variables, or performing arithmetic with fixed values often uses immediate addressing. The second is the register addressing mode. Register addressing mode is an addressing mode in which the operand is located in a CPU register rather than in memory. The instruction specifies the register that holds the operand, so there's no need to perform a memory access, making it a very fast way to access data. Here, add is the opcode, A and B are registers. This instruction adds the value in register B to the value in register A and stores the result back in A. Direct addressing mode is an addressing mode where the operand's memory address is specified directly within the instruction. In this mode, the instruction includes the actual memory address where the operand is located, and the CPU directly accesses that address to retrieve or store the operand. Here, load is the opcode, A is the destination register, and 1000 is the direct address of the operand in memory. This instruction tells the CPU to load the value at memory address 1000 into register A. Indirect addressing mode is an addressing mode where the instruction specifies a memory location or a register that holds the address of the operand rather than the operand itself. In other words, it's a two-step process. First, the CPU accesses the address in the specified register or memory location, and then it uses that value as a pointer to retrieve the actual operand. Here, load is the opcode, A is the destination register, and 1000 is the indirect address, where 1000 holds the pointer to the actual operand address. The CPU first reads the value at memory address 1000. Suppose the value at 1000 is 2000. The CPU now knows it should look at address 2000. The CPU loads the data stored at memory address 2000 into register A. Here, move is the opcode. A is the destination register, and R1 inside the brackets indicates that R1 holds the memory address of the operand. Suppose R1 contains the value 2000. This means that the memory address 2000 holds the actual operand. The CPU will go to address 2000 in memory, retrieve the value stored there, and load it into register A. Indexed addressing mode is an addressing technique where the effective address of the operand is calculated by adding a constant value called the index or offset to the contents of an index register. This is commonly used for accessing elements in arrays or lists, where the base address of the array and the position or index of an element are combined to find the exact address. Here, move is the opcode, A is the destination register, 1000 is the base address, and R1 is the index register. Suppose R1 holds the value 2, indicating that we want to access the element at 1000 plus 2, which is 1002. The CPU calculates the effective address, which is 1002, retrieves the value at address 1002, and loads it into register A. Relative addressing mode is an addressing method where the effective address of the operand is determined by adding a constant, often called a displacement or offset, to the current program counter value. This mode is frequently used for jump or branch instructions, as it allows a program to specify the address of the next instruction relative to the current location, rather than as an absolute address. Here JMP is a jump instruction, and -4 is the offset. If the JMP instruction is at address 1004, Then 1004 minus 4, which is 1000, is the next instruction to be executed. This instruction tells the CPU to jump back to the instruction located at address 1000. Base displacement addressing mode is a technique used to calculate the effective address of an operand by adding a base address stored in a base register and a displacement, often called the offset value. This mode is commonly used in complex data structure access, as it allows efficient access to memory locations relative to a known base address. Relative addressing mode and displacement addressing mode are similar in that both involve using an offset to calculate the effective address, but they are not exactly the same and have distinct uses. Relative addressing depends on the current program counter, while displacement addressing typically depends on a base or index register. Relative addressing is used for control flow instructions, whereas displacement addressing is often used for data access in complex data structures. Consider a structure in C that represents a person object with fields for age, height, and weight. Age is at offset 0, height is at offset 4, and weight is at offset 8. Let's assume the base register, EBX, holds the base address of a person. Each field can be accessed by adding a specific offset to the base address in EBX as shown here. Each move instruction uses EBX plus an offset to access different fields within the structure. This is quite similar to indexed addressing where we also use an offset. But in base displacement addressing, we can have different offset values as shown here. Stack addressing mode is a method used to access data stored in a stack, a data structure commonly used in function calls and local variable storage. In stack addressing mode, operands are implicitly located at the top of the stack and no explicit address is provided. Instead, the stack pointer, often denoted by SP in x86 processors or R13 in ARM processors, manages access to the stack's top, where all push and pop operations occur. A push instruction adds or pushes an operand onto the top of the stack, and the stack pointer is updated accordingly. It decrements in most architectures since stacks typically grow downward in memory. A pop instruction removes or opts the operand from the top of the stack, and the stack pointer is adjusted to reflect this change. In this example, push AX pushes the value in the AX register onto the stack. Push BX pushes the value in the BX register onto the stack, so now BX is on the top. Pop CX pops the top value of the stack into the CX register. Pop DX pops the next value in the stack into the DX register. Add DX, CX adds the values A and B and stores the result in DX. Addressing modes are critical in computer architecture because they define how the processor should locate the operands needed for the execution of instructions. Thank you for watching the video. I hope you learned something today. Have a beautiful day and see you in the next video.